what powers the tester when the equipment is de-energized. So inside the absence of voltage tester, there is a supercapacitor that is basically energized off of the bus when the system's energized. And when it's de-energized, that absence of voltage tester can hold its charge for up to 10 hours and can perform about 15 tests per charge. If the capacitor ends up discharging before you can perform the absence of voltage test, we also have a USB-C port underneath the unit which can recharge the supercapacitor within about 5 minutes or so. Where is the known voltage source derived from? It's a value of 3.3 volts, and it is coming from our control box and then transmitted via an IX cable, which is supplying both power and communication between the control box and the display unit on the front of the door. In doing it in this method, we're removing the hazardous voltage from being at the door and instead contained within the control box that is inside the actual unit that is being tested. So having a comparison of the way we do it today versus how we do this tomorrow, is it really required or just helpful? Well, it's not that it's a requirement, it's more so that there's an exception. You can still do this absence of voltage testing via your traditional method of testing with your multimeter, but what we've seen is that the electrical shocks and burns, fatal or non-fatal, haven't been decreasing over a period of time, and a lot of the incidents were occurring during voltage testing. So in placing this product into your system, you can reduce time and also create a safer environment where you would reduce the probability of a hazard by having this absence of voltage tester perform the test between the two phases as well as phase to ground before you're even opening the door. What sets your AVT apart from Panduit's AVT? Both AVTs are fairly similar. The only difference is Panduit's AVT is using a battery, and the battery, if it discharges or doesn't have any power, then it could be an issue. Whereas the supercapacitor, we can charge that up through the USB-C port underneath the device, and that would be the main thing that sets us apart. We're also working on higher voltages, so eventually we will be releasing those, and that would provide us with a bit of an edge as well against their offering in particular. So one of the competitor product requirement is to use a 10 mega ohm meter for test ports. Is there any limitation on i-Gard's AVT? So the 10 mega ohm meter for the test port, those are in regards to the test ports. Remember that the AVT is different and it doesn't have test ports. We are getting the voltage to our control box and it's not appearing on the front of the enclosure because we're transmitting the information from the control box to the AVT via the IX cable that we're utilizing. This reduces the hazard for that voltage to be on the front of the enclosure, and therefore there's no real requirement for any form of resistance. On our test ports, we have a very, very high impedance. I believe it's around 10 mega ohms between our test ports for our voltage test port. The unit utilizes a supercapacitor that charges off of the main bus, and if the supercapacitor happens to de-energize or lose its energy, it basically has a USB-C port where you can recharge the capacitor inside and conduct the tests you need to conduct. But typically, if the AVT is fully charged, it can perform about 10 to 15 tests per charge, and if it de-energizes or the capacitor is low, then it takes about 10 minutes to charge. Are these devices supposed to be attached to generating units or any electrical unit which is live? They can be attached to electrical units which are live, since this is a permanently mounted and installed unit, and in normal operation the AVT would indicate red lights when the system is energized. So yeah, it can be attached to generating units or electrical units which are live. When do you expect a medium voltage device will be available? At the moment, we're working on a 5 kV AVT as well as a 15 kV AVT. We're still in the process of developing it, so just stay tuned and we'll give you a timeline for that. What type of equipment is the AVT not appropriate for, specifically about high nose scientific equipment? Well, we are getting both AC and DC based measurements, and usually the unit is used when the system is de-energized. So that means that the high noise scientific equipment will also be de-energized, and as a result, the AVT can still be appropriate for this type of equipment since it's only acting as the system is de-energized. The lifetime of the supercapacitor, it has quite a long lifetime, and if there was any issue with the device, yellow lights would be indicating and would not provide a false positive or false negative in the field. Are you making an internal battery version that will last for more than several days? No, we're not going the battery route because the supercapacitor is doing a better job, and we want to stay away from batteries that in themselves have their own challenges. The battery could be dead and there's no means to charge it, so you'd probably have to replace the battery, whereas our supercapacitor and USB-C port allows us to recharge the supercapacitor to basically make sure that there's enough power to perform the test. Is the AVT only required for above 1000 volts AC and DC? The requirement is pretty much across the board. It's not discriminatory to any particular voltage on AC or DC. There are challenges when we go beyond 1000 volts AC and DC, simply because there is more voltage present and we have to find a safe way to step down that voltage through resistances or capacitances in such a way that we can get it into our control box to be analyzed. Would this device be acceptable to use getting its voltage signal from PTs instead of direct from the bus? Unfortunately, we cannot use PTs in the arrangement because UL 1436 does not allow PTs to be utilized, so we have to actually connect directly to the point of work on the bus. Regarding use in scientific equipment, your competition gives false positives in the presence of electrical noise from adjacent equipment. They indicate unsafe conditions even when electrically safe. That's interesting to know. We haven't really encountered that issue as of yet, but I'd be interested in knowing more about that. At the moment, we are in the process of getting higher rated voltages because we're getting asked quite a bit for higher voltages, especially in the DC offering as well for battery systems, and also for AC, where a lot of PPE is required to do this de-energization testing process with just multimeters, and they probably want a better method to go about doing this that is less time